You're able to see my screen?
No, sir.
I've shared it. Okay, just a minute. Now are you able to see?
Yes, sir.
Yeah. So there were 4 more problems that were left out. Right, we'll finish that off. And then we'll start the next chapter, okay? So 9th one, how many of you tried it? I asked you people to try it. So the 9th one is, let R be a relation from n to n defined by R is equal to A comma B, such that A and B belong to the natural numbers. And what are the relation between A and B? A is equal to B square. Are the following true? A comma A belongs to R. Is it right?
Yes, sir.
Yes,
A comma
sir.
A, does it belong to the relation where A belongs to the natural number? So
Yes, sir.
if you're trying to say A comma A belongs to R, then A should be equal to A square. Because what is the relation? The relation between A and B is A is the input, B is the output. The relation between input and output is input is equal to output square. So how can A be equal to A square?
Sir, since it's A comma A, B is taken at A value.
Sorry?
Since it's A comma A, B is taken as A value.
Yeah. Since the relation is the ordered pair is A comma A, A comma A, then what is the relation? A should be equal to A square. Is that right? In this case, is it right or not? So A is equal to A square. Wrong. So how you are supposed to write this? Since B is equal to A, since B is equal to A, and the given relation is A is equal to B square, implies A is equal to A square. Since it is not possible, A comma A cannot be a part of the given relation. Are you guys able to understand this? Similarly, if A comma B belongs to R, they've already told you. So if A comma B belongs to R, then A is equal to B square. That is understood. That is by default you can take it. Okay.
Yes, sir.
Since A comma B belongs to R, that implies A is equal to B square. Let this be equation number 1. If I take B comma A belongs to R, that implies B is equal to A square 2. If A comma B belongs to R, B comma A belongs to R, then these two should be the same. Is it right? A is equal to B square and B is equal to A square. Is it possible?
No, sir.
No. Right. Since 1 is not equal to 2, B comma A does not belong to R. Is it clear? Similarly, what have they told us? A comma B belongs to the relation R. Okay, here R doesn't stand for real numbers, it stands for relation R. So A comma B belongs to R, which implies A will be equal to B square. I hope it is clear. Similarly, B comma C also belongs to R, correct? Then what should be the relation?
B is equal to C square.
Okay. For A comma C to belong to R, it should imply what?
A is equal to C square.
Will you get it?
No, sir.
No, sir.
If you solve both, will you get it? No, because if I solve both, I would have got A is equal to C square if I had B this side. Correct? Since A is not equal to C square, A comma C does not belong to R. So none of them is matching. Okay, none of them are part of the relation. I hope it is clear. Right.
sir.
Can I rub this? Or is anyone copying?
Done, sir.
Done. Okay. So do the next one. The 10th one, they are trying to say A is equal to 1, 2, 3, 4. B is equal to 1, 5, 9, 11, 15, and 16. F is 1, 5, 2, 9, 3, 1, 4, 5, 2, 11. Are the following true? F is a relation from A to B. Is it right?
Yes, sir.
Yes, it is. F is a relation from A to B. Is F a function from A to B? It's very simple.
Yes, sir. Actually, no, sir.
Why?
No, sir.
2 has two
2
different.
has 2 images.
One
2
input has two
so,
different
so
outputs.
2 comma 9 and 2 comma 11. Same input, but two different outputs.
2 different out.
Yes. So how you have to write in the exam is, since 2 which belongs to A, the set A, is mapped to more than one element in set B, the given relation is not a function. Okay, got it? So this is how you need to write.
Sir, here map to means it has two outputs, no, sir.
Two images. Don't use the word output. Output is only for your understanding.
So
Okay,
two
according to mathematics, it is images.
Okay, sir.
Yeah, I use the word output and output for you guys to understand.
Okay,
Don't
sir.
use that word in exam, they might strike off. Okay.
Okay,
We'll go
ma'am.
to the next one. Yeah. We'll do the next one. So 11th one, I think that's simple. So let F be a subset of Z cross Z. Z is in bold. So what set does it imply?
Integer.
Integer set. So Z cross Z defined by F is equal to A, B, comma, A plus B, such that A and B belong to Z. Is F a function from Z to Z? Justify your answer. So what are they trying to ask is, let us say I have A is equal to 1. Okay, this problem has to be done only by trial and error method. So A comma B, A is 1 and I say B is also 1. Okay, then what they are trying to say is F of AB should be equal to A plus B. Is F a function from Z to Z? You have to go only by trial and error method. We don't have any general method to prove this. Are you guys able to understand? So you can take A as 1 and B as 1. So F of 1 into 1, okay, 1 into 1 is equal to how much?
1 plus.
So 1 plus 1, that is 2. So F of 2 is 2. Right, I hope this is clear. So F of, let us take some other number. You tell me, no? A is equal to 1 and B is equal to 2. So what do I do? F of 1 into 2 is equal to 1 plus 2. So F of 2 is equal to 3. So what do you understand? Sorry, I made a mistake here. F of 1 is 2. So what do you understand? For different elements, you have different outputs. You have different images. No two inputs will have the same output. That's what I'm trying to say. So that is, so here what should be the format of input? It should be the product of two numbers. So what they're trying to say is the product of two numbers when substituted in a given function will be equal to the sum of the two numbers. Is it possible?
No, sir.
No, sir.
Right. And
A B equal to B, sir.
what is AB equal to BC?
Like, for example, can A equal to 0 and B also be equal to 0?
Yeah, it can be. Because A 0 and 0 both belong to integer, no? It
That
need not
means
be A.
B, sir.
Okay.
A and B are equal to 0.
Okay. Then f of 0 will be 0, no?
Yes, sir.
Oh, you're trying to say that once that scenario
Yes,
is there.
so there's a possibility it can be like that, sir.
Yeah, yeah. Because see, yes, that's right. So A is equal to 0, B is equal to 0. F of 0 into 0 is equal to 0. Right? A is equal to 1, B is equal to 0. F of 1 into 0 is how much?
0.
1.
1.
So
One.
F of, because A plus B, no? So
Yes,
f of
sir.
0 is 1. So here also, here I'm getting f of 0 as 0 and here I'm getting f of 0 as 1. So is it possible? So is it a function?
No, sir.
Yes.
No, sir.
Is there anyone who's not clear? You want me to explain it again? Okay, this problem, as I told you, you can use only trial and error method to prove it. Right? Can I rub this?
Yes, sir.
So what are the last problem saying? So tell me how to do the last problem. Let A is equal to 9, 10, 11, 12, 13. F is a function map from A to N. Be defined by f of n is equal to the highest prime factor of n. Prime factor of n. Okay. Find the range. So I should write f of 9. F of 9 means f of 9 is what? Highest prime factor of 9. So what is the highest prime factor of 9 that is possible?
3.
3.
Similarly, f of 10. Highest prime factor is 1, 5. So f of 11.
11.
F of 12.
3.
What are all the factors? 1,
3.
2, 3, and 12. So highest is 3. 4 is also there, no? But the highest prime factor is 3.
3.
Similarly, f of 13.
13.
Range
3, 5,
5,
11,
11, 13.
that's it. Right? So 3, 5, 11, 13. So there are some points given in the summary also. You guys can revise for a quick revision. Apart from this, is there any doubt? Any other doubt that you have in this chapter which you're not clear with? Like this kind of a problem, I don't know how to approach. Anything like that?
No, sir.
No. Okay, if you're clear, then
Sir, I have a doubt actually. I have a doubt.
Yeah, tell me.
For finding range, we have to use only trial and error method, no, sir.
No, there is a
There's no other
method.
method.
No, there is a method, but if I teach you now, you will definitely get confused. Because
Okay.
you need to handle more functions for it. Your textbook has
Okay.
very limited functions. I'll give you some problems for practice. You try that. Okay, you guys try that. We will have one more session for discussing how to handle these range and all. First, you people try. You do trial and error method. You think about it so that when I explain things, it will be better. You can understand better. Okay.
Okay, sir.
Yeah. Even in 12th standard, the concept of range is not given that great, but it is very, very important for competitive exams. Not only for competitive exam, for you to handle the problems based on calculus, very important. Okay, but that is stressed very less. I don't know why. There is one drawback in CBSE. That is a very, very important concept. Anyways, we'll discuss about it. Don't worry.
Okay, sir.
So we'll start the next chapter. See, mathematical induction is not there. And one more point to be mentioned is you would have seen the reduced syllabus, no? So according to the reduced syllabus, we have completed 3 chapters. Because I didn't teach you trigonometric equations, but I will definitely teach you at some point because those who are there for physics, you guys need it. So it is very important topic for physics. But as time progresses, I'll teach you. Okay. So you need to practice the trigonometry part, especially till 3.3 very well. You need to ensure that you're able to apply all the identities and properties. So first chapter sets, second chapter relations and functions, and the third chapter trigonometric equations till 3.3 is over. 3.4 is trigonometric functions that I'll teach at a later point. And the fourth chapter is mathematical induction. Mathematical induction is removed. Okay. Now I'm coming to complex numbers. See, in complex numbers also the polar form and all those things are removed, but I will explain it to you because those are important. They have some connectivity with other chapters. So whichever topic has connectivity, I will not skip it. For example, mathematical induction is not that important. Okay, it is actually a very simple chapter. Even if I teach it, it's going to get completed in one day. But since it is removed, let's not take stress about it. Even if at later point you want to learn that chapter, it is not a big deal is what I'm trying to say. Okay, so now we'll start with complex numbers and quadratic equations. The name of the chapter itself is complex numbers and quadratic equations. Okay, so the origin of this concept complex numbers came from whatever you have learned last year already. So in your 10th grade, you had a chapter called quadratic equations, the 4th chapter. You had it, right? So linear equations in 2 variables, and you had quadratic equations. So in the concept of quadratic equations, to solve the quadratic equation, what are all the different methods we follow? If I give you a quadratic equation, ax square plus bx plus c is equal. What are all the different methods you will try to implement to get the solution for this? When I say solution, finding the value of x.
Factorization.
So one is
Quadratic formula.
So one is factorization, very good. So factorization means you will try to find the factors as the name suggests. You will try to find what are the factors of it and you will try to split and write it as product of 2 linear functions. Correct? So x minus 3 into x minus 4, something like that. That is right. Somebody else told me another one. What is it? You will use?
Quadratic formula.
Quadratic formula.
You will use the quadratic formula. Okay, let me take a new page. So in the quadratic equations, just a minute. The quadratic equations, the first part is ax square plus bx plus c is equal to 0. The first way of solving it is factorization. Second is, you people told me you use a quadratic formula. What does this quadratic formula mean? So x is equal to, can you tell me the formula?
Minus 3
Minus 3 plus or minus b square minus 4ac by 2a.
4ac divided by 2a.
2a.
Right. This b square minus 4ac has a name.
Discriminant.
discriminant.
So this b square minus 4ac equal to, so is called discriminant.
Sir, what is breaking?
So this is also, okay. So b square minus 4ac is called as the discriminant. You know this also. So there were certain questions, right? So what should be the condition for a discriminant for the quadratic equation to have real solutions?
Greater than 0.
So you will have something like this. If the discriminant is greater than 0, what would have happened? You will have
Distinct
real
and real.
you will have real roots which are distinct. Distinct means they are going to be different from each other. If D is equal to 0, it implies you still have real roots, but you will
Equal.
have unique. You will have the same value, equal. You can say equal also. This D is less than 0, what will happen?
Imaginary roots.
This imaginary roots are there, no? These imaginary roots is what is called as a complex number. Okay. So the origin, the opposite of a real number is what is called as a complex number. Complex numbers generally do not exist because you cannot write them. So what we have done is, but this complex number concept has a lot of application in science aspect, because there are certain series and all which I cannot explain you obviously. Those series, you take the help of the concept called as complex numbers to study many of the science concepts. Okay. So to put it on a lighter note, are you guys able to understand where the term complex number actually came from? It is coming from the concept of discriminant. That is why if you look at the name of the chapter, it is complex numbers and quadratic equations. Okay. Now the question is, how do I represent a complex number? That is what we need to know. See, if I say, I'll take the example what they've taken equation x square plus 1. So x square plus 1 equal to 0. Okay. If I ask you what value of x that you can substitute in this quadratic equation so that the answer comes out to be 0, can you tell me? So x square is equal to minus 1. We will try to solve it by pushing the constant on the other side, variables on one side. So if I ask you x is equal to what, you will tell me plus or minus square root of 1. Right? If you square which number, are you going to get a negative value? Obviously, no value, right? So you have no number whose square is going to be a negative value. So x is equal to plus or minus root 1 is what I'm going to get as a mathematical expression. So once we get this expression, if suppose I give you a question like this, x square plus 3 equal to 0, then what will you do? X square is equal to minus 3, x is equal to plus or minus root of minus 3. So here also you are not able to solve. So like this, I can have many other questions that can be framed where I don't have a solution for it. What solution? I don't have a real solution for it. Means that number does not belong to the real number system. The real number system that we know are the collection of what? Natural numbers, whole numbers, integers, rational numbers, and imaginary numbers. So apart from all these numbers, the number that is going to exist, the counterpart of it, counterpart of the real number, is what is called as a complex number. So to represent a complex number, what they have done is they have introduced a symbol. The symbol that is used is I for a number called as square root of minus 1. Right? Are you guys able to understand this point? So if you observe this, for example, I have minus root 3, then what should I do? Square root of minus 3 is there. It can be written as square root of 3 into square root of minus 1. Can I write it like this?
Yes, sir.
The square root of minus 1 is always replaced with the symbol I for us to understand. So if you see any number which is a combination of this and this, okay. So if I give you as 3i, what do you understand from here? Here the value is 3
Imaginary
into,
number.
3 into root of minus 1 actually. Actually the value that is existing is 3 into root of minus 1. This is an imaginary number. Right? But 2 is a real number because I can either call it as a whole number, or I can call it as a natural number, or I can call it as a positive integer. It's my wish, but it is a part of the real number. So this real number plus the imaginary number put together is what is called as a complex number. Are you guys able to understand? So if you have to give a general expression or a general term for a complex number, this is how it is written. So any complex number can be represented in the form a plus b into I, where this a is called as the real part and this b into I is called as the imaginary part. Why is it imaginary part? Because you have an I is nothing but root of minus 1, means there is no solution existing. Okay. So
Is it the
in,
standard form, sir?
sorry?
Is it the standard form, sir?
It is standard form. So complex numbers are represented by the symbol small z. So don't get confused between the z and the z. You always is always represented in the bold format. Wherever you see bold format, that is a set. You will just a number, just a symbol that is given that represents something else. So small z is equal to a plus ib. Okay, where a is called as the real part of z. You write it like this: Re of z, and b is what? Imaginary part of z. Imaginary part is written as im. Is there any confusion or any doubt till this time?
No, sir.
All right. Yeah. So you can make a note of it.
Right, sir.
Sure. Wait, add some pages. Copy it. Mithun, let me know once you're done.
Please, sir.
Right? So, whenever you have two complex numbers in your hand, okay? So, whenever you have two complex numbers in your hand, let's say Z1 and Z2, the two complex numbers are said to be equal. Z1 is equal to Z2 if and only if the real part of Z1 is equal to the real part of Z2 and imaginary part of Z1 is equal to imaginary part of Z2. Okay, so this is the first basic concept to be kept here. So if I give you a question, right, 4x plus I into 3x minus y is equal to 3 plus I of minus 6, where x and y are real numbers, then the value of x and y is what? So this is Z1. So Z1 is equal to 4x plus I into 3x minus y. Z2 is 3 plus I into minus 6. So what have they given? Z1 is equal to Z2. Then what all should be equal? 4x should be equal to 3. Similarly, 3x minus y should be equal to minus 6. So 4x is equal to 3. X is equal to obviously 3 by 4. So once you get 3 by 4, 3 into 3 by 4 minus y is equal to minus 6. So 9 by 4 minus y is equal to minus 6. Y is equal to 9 by 4 plus 6. That is 33 divided by 2.
Sir,
Tell me.
sir, so here 3x minus y is equal to b, sir.
Yes, 3x minus y is the imaginary part. Are you done? Next, the algebra of complex numbers. What are all the operations that we do? We can do addition, we can do subtraction, we can do multiplication, and we can do division also. Okay. So the first concept is obviously the addition of two complex numbers. If Z1 is equal to A plus IB and Z2 is equal to C plus ID. See, this C and D are variables. It is up to you. You can take it as x1 plus iy1, x2 plus iy2, like that also. It is up to you. Be any two complex number, then Z1 plus Z2 is defined as what? Okay. Now observe this. If Z1 is equal to A plus IB and Z2 is equal to C plus I into D, what is Z1 plus Z2? Z1 plus Z2 is nothing but adding the real part of Z1 and real part of Z2, that is and Z2. Are you guys able to understand this? Okay,
Sir,
this is a
could you
very
repeat? Your voice was breaking.
Yes,
no,
sir.
I'm saying if you have Z1 is equal to A plus IB and Z2 is equal to C plus ID, Z1 plus Z2 will be equal to A plus C plus I into B plus D. Means you have to add the real part separately, you have to add the imaginary part separately.
Okay, sir.
Yeah. See, this textbook, I'm writing it C. It is nothing but the real part of Z1 plus real part of Z2 plus I into imaginary part of Z1 plus imaginary part of Z2. Got it? Okay. So based on this, there are certain the addition of complex number. The first one is called as closure law. So sum of two complex numbers is a complex number. Okay. Sum of two complex numbers is a complex number. If Z1 and Z2 are two complex numbers, then Z1 plus Z2 is another complex number. For all the complex number, Z1 and Z2. Okay. Second, it is the commutative law. Commutative law states Z1 plus Z2 is equal to Z2 plus Z1. That is A plus C plus I into B plus D is same as C plus A plus I into D plus B also. Third one, the associative law for any three complex numbers Z1, Z2 and Z3 are given as Z1 plus Z2. So what you do is you add Z1 and Z2 first and you add it to Z3 next. Is the same as adding Z1 to the value of Z2 plus Z3. Okay. This is a very, very simple concept. Next is the existence of additive identity. Okay, there are two concepts you will be learning. One is called as, see guys, listen to it very carefully. One is called as additive identity and the second is called as additive inverse. They both are different. Okay, additive identity means if suppose I have a number 2, what is the additive identity of 2? Additive identity means what number I should add to the given number so that I get back the same number. What number should I add to the given number so that I get back the same number?
0.
So additive identity of any number is always a 0. Okay.
Okay, sir.
Then what is this additive inverse? Additive inverse means what should I add to a given number so that I get a 0?
Minus 2.
So minus 2 is the additive inverse of 2 and 2 is the additive inverse of minus 2. Is that clear? Okay. These two are very, very important points. Since you're learning it for the first time, it might confuse you. That is why I'm stressing on this. Additive identity for any number is always a 0. Additive inverse is the negative of the given number. right? So if you keep about it, the existence of additive identity for a complex number is like this. Remember, if I ask you a question like this, is 0 a real number or a complex number?
Real number.
Real number.
2 is a real number or complex number?
Real number.
Real number.
The question is, every complex number is a real number. Sorry, every real number is a complex number. But every complex number is not a real number, because you told me 2 is a real number. I can write 2 as 2 plus I into 0. Can I still write it in the form of a complex number? The only thing is here the imaginary part is 0. But still, am I able to write in the form a plus ib? Are you guys able to understand? So every real number is a complex number. So when I talk about additive identity, when I talked about a real number, you told me 0. But can 0 be written as a complex number? 0 plus I into 0 is what is the complex number, which is going to be the additive identity of any complex number Z. Okay, so Z plus 0 is Z. Similarly, what is going to be the existence of additive inverse? So additive inverse is the negative of the given number. So if Z is a complex number, which is given as a plus ib, then what will be the additive inverse of this? So what should I add to Z to get a 0?
Minus a minus ib.
Minus a minus ib. So minus a minus ib is called as the additive inverse of a plus ib. Are you guys able to understand?
Yes, sir.
Yes, that's good. So this is a very simple concept. Make a note of it. Can I rub this? Yes or no? The next concept of two complex numbers. See, if I have Z1 and Z2 as two complex numbers, Z1 minus Z2 can be written as Z1 plus of minus Z2. Means I am adding a complex number. So difference of complex number is like this.
So your voice is breaking, sir.
So I'm repeating again. Z1 minus Z2, I can write it as Z1 plus of minus Z2. Correct? So difference of two complex numbers is equal to sum of a complex number with the additive inverse of the other complex number. Okay.
Sir, could you repeat?
So we have, for example, which point you want me to repeat?
Z1 minus Z2. Your voice
So,
wasn't able to hear.
difference of two complex number is equal to addition. See, difference is a reverse, subtraction is a reverse process of addition. Right. So what I'm trying to say is addition, difference of two complex numbers is equal to addition of a given complex number with the additive inverse of the other complex number. Z2 is a complex number, means what is the additive inverse of it?
Minus Z.
Minus Z. So I'm adding Z1 to the additive inverse of Z2. That is what is meant by subtraction. Yeah. 6 plus 3i minus 2 minus I. It is very simple. Collect all the real terms, subtract or add. 6 minus 2 is 4 plus 3i minus of minus I. 4a.
4a.
That's it. Okay. So that's what you need to do for subtraction. Other things. So multiplication of two complex numbers. Okay, this one I will explain. Please make a clear note of it. If multiplication of two complex numbers, z1 is equal to a plus ib and z2 is equal to c plus id. Okay, if I ask you what is z1 into z2, what will you tell me? It is a plus ib into c plus ib. No doubt about this, right? So you have two terms in first one and two terms in second one. When you multiply two terms with two terms, how many terms will you get?
Four.
Four terms, right? So a into c, ac, plus I into a into d is ad, plus I into b into c is bc, plus I into I is how much?
I square.
So root of my I square is how much? I square is
-1.
root of -1. I square is -1. I cube will be -1 into I. Can I write I cube as I square into I? I square is nothing but -1. I is I only. So 1 into I is minus I. Then I power 4 is I square into I square. What is I square into I square? -1 into -1, that is +1. Are you guys able to understand? So I is root of -1. I square is -1. So I cube is -1. I power 4 is 1. Have this point in your mind. So here I have I into I, which is I square into b into d. So it will be AC plus I into AD plus BC. I'm collecting all the I terms. Plus I square is -1 into BD. So AC minus BD plus I into AD plus BC.
Sir, can you go up a little bit, sir? I'll take the I value, sir. I didn't take the I value, sir.
Yeah, take.
Done, sir.
Okay, so AC minus BD plus I into AD plus BC. Is that clear? So this is multiplication of two complex numbers. Okay. So I hope you copied this one. So you need not remember it like a formula. You can do it for individual problems. I don't suggest you to remember this as a problem. Done? Now see, what are all the properties associated with multiplication of complex numbers? So the closure law, the product of two complex numbers is a complex number. So the product Z1 and Z2 is a complex number for all the complex numbers Z1 and Z2. So if Z1 is like this and Z2 is like this, Z1 into Z2 is the product. Okay, Z1 into Z2, that is how you write it. So commutative law, what does it state? Z1 into Z2 is same as Z2 into Z1. Associative law, like you multiply two complex numbers taken together. Z1 into Z2 multiplied first, that multiplied with Z3 next is same as Z1 multiplied with Z2 and Z3. Okay. The existence of multiplicative identity, this is very important. So what did I say additive identity is? What is additive identity?
+0.
So what is the meaning of it? Additive identity.
You have to get the same numbers.
So when you add a number to a given number, you should get back the same number. So additive identity of a given number is that. So multiplicative identity means you need to multiply a given a number with a given number such that you get back the same number. If I have 2, what should I multiply with 2 to get back 2?
1.
So that is what is the multiplicative identity. So there exists a complex number 1 plus I into 0 denoted as 1, which is the multiplicative identity of the element Z. Are you guys able to understand? Then what is this multiplicative inverse? So additive inverse means you should add a number to the given number so that you get a 0. Multiplicative inverse is nothing but I should add a number such that I get the product as 1.
Reciprocal of.
It's the reciprocal of it. Okay. So the existence of multiplicative inverse. So for every non-zero complex number Z is equal to A plus IB or A plus B into I, where A is not equal to 0 or B is not equal to 0, we have the complex number A divided by A square plus B square plus I into minus B by A square plus B square, which is denoted by 1 by Z or Z inverse. You read it as Z inverse. It's called as the multiplicative inverse. Are you guys able to understand this? So I will tell you how this formula has actually come. Don't worry about it. Don't worry about it. Next, the distributive law. So the distributive law is for any 3 complex numbers Z1, Z2 and Z3, Z1 into Z2 plus Z3 is given as Z1 into Z2 plus Z1 into Z3. Similarly, Z1 plus Z2 into Z3 is given as Z1 into Z3 plus Z2 into Z3. Okay, this is what is called as the distributive law. Now, I will explain this multiplicative identity alone or multiplicative inverse. So multiplicative inverse is written as Z inverse. Okay, if Z is equal to A plus IB, then Z inverse is given as 1 by Z. Correct? So
Yes.
what is 1 by Z equal to? 1 by A plus IB. Okay. So whenever you have a complex number in the denominator, see the concept I'm going to teach you now is also used for division of complex numbers. Whenever you have a complex number in the denominator, you can rationalize it. So when I say rationalize, you multiply with its conjugate. So the conjugate of A plus IB is A minus IB divided by A minus IB. For example, when you have 1 by 2 plus root 3, what will you do? You will multiply with 2 minus root 3 and divide it with 2 minus root 3. You rationalize it. The same thing. Instead of root 3, I am writing I into B. Okay. So what will happen to the numerator? A minus IB divided by
A square minus
I into AB plus I into AB minus I square into B square. Right? So minus I into AB plus I into AB will get cancelled. You will have A minus IB divided by A square minus I square is nothing but minus of minus 1. It is plus 1. So A square plus B square. So 1 by Z is equal to this thing. So 1 by Z is equal to A divided by A square plus B square minus I into B divided by A square plus B square. So this is the multiplicative inverse. Is it clear? So now if you verify, this is the same thing that would have been given there. So A divided by A square plus B square minus I into B divided by B square, A square plus B square. Is it clear?
Yes, sir.
Now understood how it has come. Now make a note of it. This also you need not memorize. You can derive it. Okay. As you practice more problems, this will come fast. Done with this?
Yes, sir.
Now write down the next heading as conjugate of a complex number. Okay. Conjugate of a complex number. If z is equal to a plus ib, for z is equal to a plus ib, z bar is called as the conjugate of z given by z conjugate is equal to a minus ib. Okay, to put it in very simple terms, conjugate of a complex number means changing the sign of the imaginary part.
Okay,
Example, conjugate of 5 plus 3i will be 5 minus 3.
minus 3.
Similarly, conjugate of 2 minus 4i will be equal to
2 plus 4i.
2 plus 4.
as simple as that. You have to change the sign of the imaginary part. That's it.
Sir, so Z bar means it's conjugate, sir.
So z bar is conjugate, yes.
Okay.
Okay, don't get confused between z bar and z inverse. They both are different. Z inverse means multiplicative inverse. Z bar means just a conjugate. Okay, next. The next is called as the modulus of a complex number. So if z is equal to a plus ib, then mod z is given as square root of a square plus b square. Okay. So z is equal to a plus ib means mod z is given as a root of a square plus b square. Okay, don't write it as only a square plus b square. Similarly, an important point to be noted is a complex number multiplied with the conjugate of the complex number is equal to the modulus of the z square. Got it?
Okay, sir.
Yeah, tell me.
Understood, sir.
So somebody is asking a doubt from the back. Who is it? Okay. So make a note of this, guys. So going forward, next time onwards, if you see z is equal to a plus ib, z conjugate is a minus ib. If you do the multiplication of a complex number with the conjugate of it, you can directly write it as a square plus b square. Okay. Next. So division of a complex number I've already taught you. Okay. I'll tell you, see. If you have z1 by z2, where z2 should not be equal to 0. Okay. If you have z1 by z2, then what you need to do is multiply z1 with the conjugate of z2, and what will happen to the denominator? z2 will be multiplied with the conjugate of z2. So you will have z1 into z2 conjugate divided by mod of z2 square, because I told you z into z conjugate is the modulus of that complex number square. Okay, let me take an example and explain it. If I have 2 plus 3i divided by 3 minus 4i, what should I do?
Multiplied by 3 plus 4i, both numerator and denominator.
Okay, so what will happen to the numerator? 2 into 3, 6. 2 into 4i plus 8i. 3i into 3, 9i. 3i into 4i minus 12. Did you understand why I wrote minus 12? 3 into 4 is 12. I into I is I square. I square is minus 1. Okay. Divided by, when I told you, you multiply a complex number with its conjugate, you can directly write a square plus b square. That is nothing but 9 plus 16. So 6 minus 12 minus 6 plus 8i plus 9i, 17i divided by 25. So minus 6 by 25 plus 17i by 25. This is the answer. So in this chapter, the ultimate aim is you should write everything in the form of a plus ib. There should not be two i's in the same question. Only one I should be there.
Okay.
Is this clear? So is it clear till this step?
Yes, sir.
Okay. The last
Could you
concept.
just go back for a minute?
Sure.
Okay, sir.
So listen, the next concept is power of I. I have already explained it to you. Okay. So I've already explained the concept of power of I. But I'll write it again. I power 1 is I. I square minus 1. I cube minus I. I power 4, 1. Okay. Then what is I power 5 equal to? I power 5 can be written as I power 4 into I. But what is I power 4?
1.
So it will be I. So I power 6 is I power 4 into I square. So I power 4 is 1 into I square is minus 1. So it will be minus 1. So I power 7 is
minus
I
I.
power 4 into I cube.
I cube. I power 4 is 1. I cube is minus I. So it will be minus I. I power 8 is I power 4 into I power 4. That is 1 into 1. Okay, so you are able to observe the pattern gets repeated. I minus 1 minus I 1. I minus 1 minus I 1. So what do you think will I power 9 be equal to?
I.
I power 10 will be equal to minus 1.
Minus 1.
I power 11 will be minus I. And I power 12 will be equal to
1.
So if in the same format I ask you a question like what is I power 243, what will you say?
Minus I.
So how do you get it?
Sir, then I power 3 and I power 7 are same value, sir.
Yes, I power 3 and I power 7 has the same value. Similarly, I power 3, I power 7 and I power 11 has the same value. So in this format, what will be the value for I power 243? Somebody told the answer.
Minus 1. Minus I.
Minus I. Because you can write it as I power, you have to divide this number with 4. Okay, if you divide this number with 4, what do you get? You can write it as 4 into, so 4 into what? 4 into 60 plus 3. Can I write it like this?
Yes, sir.
So I power 4 into 60 into I cube. Because the powers are getting added means the base should be the same. So I power 4 into anything is 1.
1.
Because you observe I power 4 is 1, I power 8 is 1, I power 12 is 1. So 4 into 1 is 4, 1, 4 into 2 is 1, 4 into 3 is 1, it keeps going. Into, what is the value of I cube?
Minus I.
So answer is minus. That's it. Similarly, I power 568 or 565, what is the answer? So divide 565 with 4.
I.
1, 4, 16, 4, 16, 1, 5, 4, 1. So I can write it as I power 4 into 141 plus 1. Correct? So I can write it as I power 4 into 141 into I power 1. I power 4 into 141 is 1 into I power 1 is I. So answer will be I.
Yes, sir.
So that's it. So you have to divide all the numbers with 4, and using that division algorithm, you have to write it in that format. So to put it in simple terms, when you divide the number with 4, you have to just I power the remainder. It will give you the answer.
Okay, sir.
Yes, sir.
Okay, so these are all the problems. The square root of negative real number, these are all we will see later. So this is a very simple exercise which we can maximum solve it in 15 to 20 minutes. So tomorrow we will be starting with the example problems. Okay. So I suggest you to revise all these concepts and come for tomorrow's class. Okay.
Yes, sir.
Okay, sir.
Any other doubt for today's class?
No, sir.
Okay. Okay, then we'll wind up. Let's see you guys tomorrow.
Thank you, sir.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.